Let's talk about chirality. I just said chiral carbons or chiral compounds are compounds that contain four different groups on it. So a chiral carbon is a carbon that contains four different groups on it. So now let's take a look at this one here. We have here to be CH3, CH2, then a carbon is CH, then a CH2, then a CH3. So now don't let this skeletal structure confuse you. It is very easy to bring out. So we have this compound to be C, then C, then C. So we have 1, 2, 3, 4, 5. We have 1, 2, 3, 4, 5. So on the center carbon we have an OH, right? We have an OH. So now, if a carbon has four different groups attached to it, it is chiral. So now let's bring out the hydrogens here. We have each carbon is supposed to have four bonds. Maximum number of bonds will be 4. So we already have one bond here. So we should be having 2, 3, then 4. Then here we already have 1, 2, 3, 4. We have 4 bonds already. So we have 1, 2, 3. So we're supposed to have an hydrogen here to make it 4. So we have 1, 2. So we have to make it 4. Then we have only 1. Then we make it. So this is same thing as this. So questions comes out like this. They don't really bring out this kind of structure. They bring it in skeletal form to be more simple on naming. So now take a look at this carbon. Is this carbon chiral? I just said a chiral carbon is a carbon that has 4 different groups attached to it. So now we are obviously seeing hydrogen, hydrogen, hydrogen. This is 3 hydrogen on this carbon. So this carbon can't be chiral. Let's take a look at this one. We already have 2 the same hydrogen attached to it, so it is not chiral. Then look at this. We have this is a CH2. This is a CH2, then a CH3, a CH2, then it is bonding to this same carbon bonding to an OH, bonding to an hydrogen. So we already have 3 different groups attached to it. So now we also have the CH2, the CH3. So this, let's take a line here at the center of this carbon. So let's take a look at this side. We have CH3, CH2. We have CH3, CH2. So these two sides are equal. They are both same. So it is this carbon bonding to similar C2H5 hydrogen OH. So to say this compound is non-chiral, it is achiral. It is achiral or achiral. So now let's take a look at this other part. It is compound chiral or non-chiral. So this is same as a CH3. So this carbon is CH3. It is obviously non-chiral. CH2 non-chiral. CH2 non-chiral. CH3 non-chiral. So this compound is still non-chiral. So note that number of stereoisomers is gotten from the number of chiral carbons in the compound. So if we have this is our formula for number of stereoisomers, 2 raised to the power n, where n is equal to number of chiral centers. So now we didn't have any chiral carbon here, no chiral carbon here, so we'll place it to be 2 raised to the power 0. So if you have a calculator there, you type 2 raised to the power 0 is 1. 2 raised to the power 0 is 1. So the number of stereoisomers is 1. Alright? So Let's take a look at this compound. Is this compound chara or achara? This carbon here, you can bring out the structure yourself on your notes if you have a note there. This compound is having a CH3, so it is non-chara. This is having a CH2, it is non-chara. Then this carbon is bonding to this part, an ethyl group. This is an ethyl. This will be CH3, CH2, which is C2H5. This is from the alkyl group. So this is bonding to this part. It is bonding to a CH3. So this CH3 is from the C2H5 we have here, and also it is bonding to an hydrogen. So this carbon is a chara carbon. This last carbon here, it is bonding to an hydrogen and hydrogen and hydrogen, so it is not chara. So we have a number of chara centers to be 1. So if they ask you what is the number of stereoisomers, number of stereoisomers will be 2 raised to the power n. So anywhere you see n, you place the number you get for your number of chara carbons. So we have 2 raised to the power 1, so it is equal to 2. So this is our number of stereoisomers. Then we have 1. The chirality of that compound is 1. Now let's take a look at this compound. Is this compound chara or achara? Though it is somehow big but very easy to name. You can pause the video, then name it yourself before we proceed. Now let's continue. This first carbon is always a CH3, so this carbon can be chara because they're having a 3 hydrogen. This one is having this whole compound, bonding to this whole compound, then having an hydrogen here. Then we have this methyl group, then we have an hydrogen here. So this compound, this carbon here is chara, so it's bonding to an OH, an hydrogen, a methyl group, then this whole compound here. So this carbon is chara, so we have it to be 1. We have it to be 1. Let's continue. This carbon is bonding to this side, bonding to this side. So we have 2 bonds left. So it will be hydrogen, hydrogen. Okay. So now same with this part. It's bonding to this side, bonding to this side. So we have 2 bonds left. So we have it to be hydrogen, hydrogen. Okay. So now let's take a look at this part. Is this carbon chara? We have this whole compound, this carbon bonding to this whole compound. We have this same carbon bonding to this NH2. Then we have this carbon bonding to an hydrogen. But let's look at this, if it is chara or achara. Let's draw a line here. So we are dividing this part. So how many carbons do we have here? We have this 1, 2, 3, 4. We have here 1, 2, 3, 4. And now the OH is going like this. The OH are both at the second carbon. Going like this at the second carbon. If you are going like this, it is at the let's count from here 1, 2, 3. At the third carbon, count from here 1, 2, 3. So now these 2 compounds are said to be similar. They are said to be same. Okay. So now this carbon, is it chara or achara? It is not chara because it is having a similar carbon, it's a similar compound and a similar compound, 2 different compounds. And I said a chara carbon is supposed to contain 4 different groups attached to it. So now this compound is said to have, this one is said to be 1, 0, 0, 0. Then same with this 0. Then look at this compound again. This one is bonding to everything here, bonding to a CH3, then bonding to an hydrogen. So this compound is chara. So how many chara compounds we have? The chara carbon is 2. So what is the number of stereoisomers? The number of stereoisomers is always 2 raised to the power n. So n is the number of chara carbon. So we have it to be 2 raised to the power 2. So 2 raised to the power 2, we have our stereoisomers to be 4. Stereoisomers to be 4. Now let's take a look at this one. Let's take a look at this one. Does this compound have a chiral carbon? That's a question for yourself. Okay, let's take a look at this part. This is a cyclic pentane having a branch that have 1, 2, 3, 4, a butane, then a methyl group. This is a butyl and a methyl group. Okay, so now let's take a look at this. I just said each carbon is supposed to contain 4 different groups. So now we have, and also a carbon is supposed to be bonded to 4 different bonds. So we have it to be this carbon to be, once you have a sharp point, every sharp point has a carbon. Every sharp point has a carbon. That's why it is built like this. So every sharp point you are seeing, they are having carbons. Okay. So now we have here to be having an hydrogen, 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 hydrogen. Now, is this compound, this carbon chiral? No. Is it chiral? No. Is it chiral? No. This carbon, is it chiral? No. This is not chiral, not chiral, not chiral, not chiral. Let's take a look at this compound. We have here, this carbon is bonded to a CH3, bonded to this side, bonded to this whole side, bonded to this whole side. So this carbon is said to be, then here we have an hydrogen. It's said to bond to a CH3, this whole compound, then this whole compound, then a hydrogen. So this carbon is said to be chiral. Take a look at this other side. This other side, this carbon is not similar to this because it is already having a methyl group. This is having a butyl group, so they are not same. So now we have here to be bonded to this whole compound, bonded to this whole compound. This is bonded to this whole side, then bonded to a hydrogen. So this side is said to be chiral as well. You get what I'm saying? So how many chiral carbon do we have here? We have it to be 2. 2 chiral carbon. So the number of stereoisomers should be 2 raised to the power 2, which is equal to 4. Alright, so now this should be the end for stereo, so for chirality. So now in this video I'm going to be discussing about how to name the EZ configuration, how to name the cis and trans, and also the EZ configuration.
Learning online haven't been more fun. Exquisite Online Tutorials is a household name when it comes to academic excellence in online tutoring of 100 level students to 100 level students and college entrance examination candidates. With the power of artificial intelligence and human studies, Exquisite Online Tutorials have been able to interact with the intelligence of students worldwide, making the good ones better and even the better ones best. Just like Science Bob, Exquisite Tutorials has a great faculty of erudite tutors that inject knowledge, whether science or business management, to the cerebrum of her students. QTME lectures and other college entrance examination lectures are going on as well. Do you still need a physical tutor? No. Exquisite Tutorials got you. Please subscribe to our YouTube channel and follow us on Twitter and Facebook.